Since factoring is multiplication backwards, we will start with the multiplication problem to learn how to factor. So here we have x plus p multiplied by x plus q. As you can see, this is a binomial multiplication problem, so we can use FOIL. So first we start x to x, which gives us x squared, x to q, which gives us q times x, x here, and we have p times q here. So as you can see, this multiplied out gives us this, which we can simplify to this by combining like terms. So when we're trying to factor, we want to find two numbers, p and q, in which case, when we multiply p and q, we get the constant term at the end, and when we add p and q, we get this coefficient for this x term. So for example, if we have something like x squared plus 6x plus 8, we're looking for p and q, where p and q added up would be equal to 6, and p times q is equal to 8. In this case, p and q would be 4 and 2, because 4 plus 2 is 6, and 4 times 2 is 8. Here are the steps for factoring trinomials when a equals 1. As we know, ax squared plus bx plus c equals 0 is the standard form of a quadratic. When a equals 1, this becomes a little bit simpler, and it's just x squared plus bx plus c equals 0. Our first step is to identify the parts a, b, and c. Our next step is to write down all the factor pairs of c, basically all the factors that can multiply to this c. Our third step is to identify which factors will sum up to b. And lastly, we can substitute that factor pair into two binomials, and we can check our work by multiplying these two together. These steps cannot be used to solve every trinomial when a equals 1. It can be used to solve the more simpler ones. But when you're just learning how to factor, this is good enough to get you through those problems before we learn about the quadratic formula. Before we start with some practice problems, I want to review a few important notes. For this video, in these problems, a will always be equal to 1, which means that we're looking at something that looks like x squared plus bx plus c equals 0. So we're assuming that x plus p multiplied by x plus q will equal to x squared plus bx plus c. My last note is about the c right here and the signs to watch out for. If c is positive, we know that both p and q are both positive or both negative. This is because when you multiply two positive numbers together, you can get a positive value. Or if you multiply two negative values, you will also get a positive value. This is because the signs will cancel out. On the other hand, if we know that c is negative, we know that p is positive and q is negative, or q is positive and p is negative, vice versa. Basically, one of the numbers will be positive and the other will be negative. Let's get started with our first practice problem. Here we have x squared minus 5x minus 14. So we're looking for p and q, where p plus q is equal to negative 5, and p times q is equal to negative 14. Because it's a negative 14, we know that out of p and q, one of them needs to be positive and the other negative. Let's start by writing down the factors that multiply up to negative 14. So we can have 1 and negative 14, 2 and negative 7, 7 and negative 2, and 14 and negative 1. These are all the potential factors, so let's try to see p plus q, what adds up to negative 5. 1 and negative 14, negative 13, 2 and negative 7 is negative 5, 7 and negative 2 is 5, 14 and negative 1 is 13. As you can see, we're looking for negative 5 here, so we know p is 2 and q is negative 7, which means it is x plus 2 and x minus 7. This is our factored answer. we can actually check our work as well. So if we factor this out, this gives us x times x, which is x squared, x times -7, which is -7x, 2 times x, which is 2x, and 2 times -7, which is -14, which gives us x squared minus 5x minus 14, exactly what you see above. For this question, we have x squared plus 9x minus 10. Once again, we're looking for p plus q, which is equal to positive 9, and we're looking for p times q, which is equal to -10. Do we know? P and q, one of them is negative, and one of them is positive. List out p and q. So p could be 1, and q could be -10. This could be 2 and -5. Could be 5 and -2, or 10 and -1. So now, let's go through p plus q. 1 minus 10 is -9. 2 minus 5 is -3. 5 minus 2 is +3. And 10 minus 1 is 9. So we know our answer is 10 and -1. So we can write x plus 10 and x minus 1 is our factored form. And just to practice, we can check our answer again, and we can get x times x is x squared, x times -1, which is -x, 10 times x, which is 10x, and 10 times -1, which is -10. So our answer is x squared plus 9x minus 10 simplified, is the same as above. Here we have x squared plus 6x plus 9. So, same as before, we have p plus q equals 6, and p times q equals 9. Because this 9 is positive, we know that both p and q are either both positive or both negative. So we can have 1 and 9, 3 and 3, -1 and -9, and -3 and -3. As you can see here, p plus q is 6, so that's what we're looking for. So 1 plus 9 is 10, and 3 plus 3 is 6. We can actually stop here because we know that we already found our perfect pair. But also, as you can see, both of these numbers are negative, so negative numbers added together will not give us a positive 6. We don't even have to check these two. So, our answer is x plus 3 times x plus 3, which is actually equal to x plus 3 squared. And there's a special term for this. It's called a perfect square trinomial. So, x squared plus 6x plus 9 is a perfect square trinomial because this trinomial is just a binomial that's squared. We're trying to factor x squared plus 9x plus 20. Like before, we know that p plus q is going to equal 9, and p times q is equal to 20. If we start out with the factors, we know that p and q have to both be positive or both be negative. However, if we look at p plus q, we know that p plus q is positive, which means that p and q are actually both positive. This is because if we have two negative numbers, it's never going to give us a positive number. So, let's just look at the positive factors to save some time. So, 1 and 20, 2 and 10, 4 and 5, 5 and 4, 10 and 2, and 20 and 1. As you can see, around this halfway point, we're kind of repeating factors, just switching the p and q, but those are replaceable anyways. We actually only have to check these top ones. So, p plus q, 1 plus 20 is 21, 2 plus 10 is 12, and 4 plus 5 is 9. So we got our answer right here. So we know that the answer is x plus 4 times x plus 5. Here we have x squared minus 10x plus 24. So we know that p plus q is going to be negative 10, and p times q is going to be 24. Now, this 24 is positive, so we know that p and q are either going to be both positive or both negative. But let's take a look at this p plus q here. The sum of p and q is going to be negative 10, which means we know that both p and q are going to be negative because two positive numbers is not going to give us a negative number. So p and q are both negative. So let's only look at the negative factors to save some time. So negative 1 and negative 24, negative 2 and negative 12, negative 3 and negative 8, negative 4 and negative 6. These are all the factors because as soon as you get to negative 6, negative 4, we're going to repeat them and just switch p and q. And as we talked about, p and q are just variables, so the order doesn't matter. So now we can look at the sum of p and q. We have negative 25, negative 14, negative 11, and negative 10. So we know negative 4 and negative 6 is our pair. So the answer is x minus 4 times x minus 6. And that's our factored version. If you multiply out to check it, you'll get x squared minus 10x plus 24. We've reached our final challenge questions. Can you factor 2x squared minus 26x plus 80? Pause and comment the answer down below. Now, let's get started. You might be saying, this entire video we've only been factoring things with the coefficient of 1 for the x squared. Can we use the same method for this question? And the answer is sort of. We can if we can make this into a form that we recognize. So, if you noticed, all of these numbers here are divisible by 2. We can factor out the 2 first. So, if we group out the 2, this gives us x squared minus 13x plus 40. Now, this might look a little bit more familiar to you. We can use the same method as before. So, p plus q is equal to negative 13, and p multiplied by q is equal to positive 40. Because this 40 is positive, we know that p and q are both positive or both negative. Let's take a look at the sum of p and q. That's a negative number, so we know that p and q are both negative. This is because the sum of two positive numbers is not going to give us a negative number. So we can look at the negative factors only. So we have negative 1, negative 40, negative 2, negative 20, negative 4, negative 10, negative 5, and negative 8. After this, we get negative 8 and negative 5. And as you can see, things will start to duplicate, just flip flop. So we can end with these 4 factors here. So let's look at the sum of p and q. Negative 1 and negative 40, negative 41. These 2 here is negative 22. Going to give us negative 14. This gives us negative 13. So again, negative 13, we found it. It's going to be negative 5 and negative 8. So x minus 5 and x minus 8, how you factor this inner quadratic. As you can see, we have a 2 outside. Our final answer is 2 times x minus 5 times x minus 8. And that's the end of this video. Thank you so much for watching.